Hey yo Islanders, welcome back to another episode of Islander Robotics, where today I'm going to be explaining to all of you how recursion works and why you need recursion to be a proficient programmer, as well as recursion actually makes your life a lot easier as a programmer. And the final thing I'm going to show all of you is that you can actually use this to make some art. So sit back, relax with your favorite snack, and let's get started, shall we? And for all of those that are watching that are part of the Islander community, thank you so much for hitting that subscription button. For those of you that are just joining and are new to this channel and you haven't decided to hit that subscription button, please consider hitting that subscription button, because on this channel I teach all of you robotics through machine learning and artificial intelligence. Now I'm going to bring myself up into the little corner right about, ooh, this is weird. I'm gonna be down in that corner, okay? And my iPad screen is gonna come up in 3, 2, 1. I have my iPad all up on here, as you all can see, and we have this little function right here, def function. This is just a really basic pseudocode of a recursive function, where we're just saying function for we're initializing it as a Python function called function, and the input argument we're going to be passing in is number. All right. Now with recursion, you always need to keep in mind that you have to have a base case. Reason being is because if this wasn't here, well, this how recursive works is that this function is going to call itself within its own function. So if you notice right here, I'm calling function again. So I'm returning a number plus function of number minus 1. Now if this if statement wasn't there, what would be happening is that this recursive function would be going on and on and on and on and on, essentially being an endless loop. But because we have this base case, essentially what it does is it causes the computer to break out of this recursive call. And it does that in this case by saying when number that we're passing into is equal to 0, return 0. Other than that, return number plus function of number minus 1. So let's just say number equals 2. Alright, so we're going to pass in 2, and 2 is not equal to 0, so that is false. And then so this becomes 2 plus function of 2 minus 1, and then the function gets called again. So now number is 1. Alright, so number is not equal to 0, so it's going to become 2 plus 2 minus 1 plus 1 so far. Well, actually, yeah, plus 1, and then number, and then since it's not equal to 0, it's going to go to the return statement, which is number, which is 1, and it's going to become 1 minus 0. Alright, so now this statement's going to go back up to the beginning, where now we're going to equal 0. 0 is equal to 0, so we're going to return 0. So instead of doing this, this is going to equal 0. So now it's actually 2 plus 1, which equals 3. Alright, so another way to think about it is this way. We have 2, and we want, well, if you've taken stats yet, you'll know permutation combination. This is that same idea, right? Recursive functions is used in permutations and combinations. So 2, nope, I don't want that. So let's say 3. We're going to keep going until n minus 1. So 3, 2, 1, 0. Alright? 4, 3, 2, 1, 0. Alright? Now what's really great about recursive calls is that it requires less computing power by comparison to what you could normally use as a while loop or a for loop. The way to think about a recursive statement is that you can essentially use it in the place of a for loop or a while loop. When you're trying to save on memory and you're trying to make your code more proficient, you want to use a recursive call. As you saw in my last video, the one before that, well, 2 videos ago, you'll notice that I was talking about recursive calls in that video as well. They really do make your life a lot easier, as well as, I'm going on to a tangent, but anyways, I feel like I am making it more confusing than it has to be. What I'm going to do is I'm going to go into a time lapse, and we're going to start now. I'm going to actually start setting up the code for all of you, and then I'll explain the code once we're all done. All right, I'm going to actually bring up 3 functions, and I'll explain all 3 of them on how they are recursive functions in just a few seconds for you, and probably a few minutes for me. So I'll see you all in a few seconds. Bye! Hey Islanders, I'm back and I got 4 new functions for all of you. The very first one we're going to talk about is called sum. I don't know why all that's up. And sum's going to be over here on line 1. Now, you may see a resemblance to a code that we were talking about earlier. To be honest, this is the same exact code, same exact function I was using to explain to all of you what recursion is. Now let me just run through it again for all of you. First line 1 is just going to be the function definition. That's just us creating the function and the function call. Now we're going to be passing in one input argument, and that is going to be number. Number is extremely important in this function. Reason being is because on line 2, that is when we're setting the base case. So stating when number equals 0, we want to return 0, stopping the whole recursive function. Alright, so after that we're going to be return 0, and after that we're going to be returning number plus number plus sum of number minus 1. So therefore, remember back in the video, back when I had the iPad up, 2 plus the sum of 2 minus 1 is going to be equal to 3. Alright, probably don't have, this is a fun little function to play around with because it helps you understand recursion. Now another function you can do within recursion is the factorial function. Alright, so right on line, line 5 is basically the same exact as sum. Factorial is virtually the same thing. The only difference is the base case, which we'll be going over, as well as what is it returning. Now the base case on this one is we want to keep an eye on for when the number that's being passed into factorial is equal to 1. Therefore, when it does hit that number, we want to return 1. Alright, so that's exactly what's going on 6. It's just stayed in the base case, and then 7's returning what we want to be returned so that the whole recursive call gets broken. Alright, then underneath it, that's when we're actually calling this function recursively, where we're saying return the number times factorial of number minus 1. That's the cool thing about factorials is recursion, is you can really play around with, you have a whole boatload of different use cases for recursion. These are some very, very simple examples, but as you start to understand recursion, you can do a lot more interesting stuff within recursion. Like for instance, what we're going to be talking about on line 10. Which is unordered pair. Now, I can try explaining it to all of you, but what I'm going to do first is I'm going to actually run the code and then I'll explain that code afterwards, alright? So we're going to actually just pop down to line 30 where I'm just saying print the sum of 2 and then also print factorial of 2. So let's just hit run and then I will come back to line 10 and explain the whole thing, alright? Hey Islanders, so this is editing Will right here, and I noticed that this portion of the code actually has an error. Instead of allowing all of you to view that version of the code, I'm actually going to show you the proper way to do this code. And real quick, I'm just going to hit run on my code and show all of you. So sum is exactly the same as what we did on my iPad. It's going to equal 3. Hence how we got 3. Now factorial, if you notice, is 2. And our input argument is 2. That makes sense because remember, factorial works off of multiplying the number of number minus 1. So 2 times 2 minus 1, which is 1. So 2 times 1 is 2. Now if we change this to 3 and hit run, we're going to get 6, which makes sense. So it's 3 times 2, which equals 6. 6 times 1, which equals 1. Alright, now underneath you're going to notice the unordered pairs. I haven't yet explained it, but I just really quickly want to go over the output of it, which is going to be 1, 2, 3. So you notice our input argument is right here. It's on line 36. It's for the function of creating. And creating's input argument is going to be 3. So 1, 2, 3, and then 3, 2 and 1 swap. So 2, 1, 3, and then underneath it goes 3, 1, 2. Alright? So 2, and in this circumstance, 3 and 2 switch, and then going down 1, 3, 2, and so on and so on and so on, all the way until you get 3, 2, 1. Those are the unordered pairs of 3. Now let's go over the code so you all understand how we actually got the answer to this. So creating essentially is like it's a driver function for unordered pairs, meaning this. Really, when you're doing a recursive function, you don't really want the user to interact. And in the circumstance of us creating this unordered pair, the way that I design the code is that I just want the user to input one single number, and then the code takes care of the rest. So because that is just one single number, it's not a list, we have to therefore create that list, hence why it's called creating. Line 29 is the function definition for creation, and it's literally a 2-line function where we're using list comprehension to populate this list. List comprehension is a very crucial thing for any Python programmer to learn. If any of you want to see this video, a list comprehension video, then leave a comment down in the comment section down below, and if enough of you thumbs up that video, then I'll be glad to. But anyways, so we're going to use the list commit. We're going to use list comprehension as well as the built-in list method of Python to populate this, where we're going to say array equals list parentheses range. Range is a really cool thing to have, all right? And I actually need to do one thing because I was messing around with this. Actually, no, that's a great point. So range is a very cool thing to have, to understand. Range doesn't go all the way up to the number that you're specifying. It's number minus 1. Alright? But in the circumstance of this code, I actually took this out for a reason to show all of you. Range is always going to start at 0. That's why it's n minus 1. But in the circumstance of my application, I want it to start at 1. So I'm going to say 1 here, and then comma. If you want to start at 0, code's down in the description bar down below, so go check it out, make some changes, have as much fun as you wish to have. Then after that, this is where we actually call the unordered pair. So this is essentially like the beginning of the maze, where creation is going to call unordered pair. We're going to start at array, and we're going to pass in the input argument of 0 because we want this array to start at index of 0. Yes, we specified 1 as the number being populated, but 1 isn't in index 1, 1 is in index 0. Alright? So therefore, since we want access to 1, we're going to say 0, and then number is going to actually be this number. Once that's all defined and the code hits line 31, we're going to therefore go back up to line 10. Line 10 is the function definition for the unordered pair. We're going to just say def unordered pair. We're going to pass in 3 input arguments: array, number 1, and number 2. Number 2 is actually what we're going to be keeping track for our base case. And you can see that on line 11 where we're saying if number 2 equals 1, then print this as well as return. Yes, that is a base case. You don't really have to so the base cases that we had here, those aren't the only type of base cases that you have to have. As long as when you hit your base case, you kill the recursive call, it doesn't matter how you do it. As you're going to see in later portions of this video, because I do use a different way to end the recursive call later on in this video, as well as keep on paying attention because I do have a competition coming up later in this video. But anyways, on line 13, we're just saying return. Line 12, we're printing. So print. Inside of Python, you don't have to do a for loop to print. You can just say print, and it prints the whole array. Now, if you want to format it in a specific way, you have to use a for loop in order to do that. But if you just don't mind that it has brackets on each side, then go for it. On line 15, this is a recursive. This is going to be the first recursive call that we have within this function. Where once we hit line 15, it's going to go back to the beginning. After line 15, we have a for loop. You can actually have a for loop inside of a recursive call. Yes, a for loop can be used in place of a recursive call can be used in place of a for loop. However, it doesn't mean you can't have it within a recursive call. The reason why we have this for loop is to actually to move around the variables within the list. So when we want to move 3 and 2 to move around, then it's all because of this for loop within this recursive call. The reason why 2 and 1 switch is because of this first if statement right here, where we're saying if number 2 modulus 2 equals 0, meaning essentially if it's an even number, then we're going to say temp equals array of I equals array of number 2 minus 1, and we're going to make array of number 2 minus 1 equal to the temp. This is a very simple swapping function within. You can actually adapt this into any programming. It's a very simple. Essentially, whenever you want to swap two things inside of an index, you can use this method of swapping. After that, we're going to be calling, and we're going to be saying else, and we're going to be calling this swapping function. I mean, the code within line 19 to 22 is essentially the same thing as what's going on from line 23 to line 25. They're exactly the same. The only difference is we're swapping the values of 0, not I. On line 22, for temp, we're setting equal to whatever the value inside the index at I is, we're going to set temp equal to 2. This case, we're setting temp equal to whatever values within the index of 0. All right, so that is why we have this if-else statement. You do this, it's not going to be as nice as this. It's going to look a little funky because it's only going to apply when number 2 is an even number. But after we get out of these if and else statements, we're going to then do a recursive call again for this function. All right, really that's the gist of this code. If you have any questions for this section, I'm sure I'm going to say this in a couple of seconds, but leave it down in the comment section down below. And while you're on your way down there, go ahead and hit that like button to let me know how much you are enjoying this video so far. Now it's time for me to go to present me, and thank you so much for watching to this point. There's a lot more to come, and like I said, there's going to be a competition coming up later in this video, so please stay tuned. All the code that's in today's video will be down in the description bar down below. All right, there is one recursive call that is really famous within the mathematics community as well as the computer science community, and that is called Fibonacci effect. And the Fibonacci effect is actually a really cool algorithm, and what that is I'm actually going to bring up the iPad right about now, and I'm going to show all of you a little bit of the understanding behind the Fibonacci effect. And yes, when you're watching this, you're probably going to ask yourself, is this really possible to be doing it recursively? I promise you it is. Alright, why don't I bring up the iPad real quick. Alright, my bad. It's not called the Fibonacci effect. It's called the Fibonacci sequence. I'm sorry that I misspoke. But anyways, I'm going to bring up the iPad and I'll show all of you a little bit of the background behind it. So, I have it up real quick, and this is how the Fibonacci sequence works. Is we have these numbers, 0, 1, 2, 3, 4. Underneath is the numbers within the Fibonacci sequence. And the best way really to understand it is that x is going to equal x of n minus 1 plus x of n minus 2. So what I'm saying here is x of 3, not minus, x of 3 is going to equal the value of x of 1 plus the value of x of 2, right? So, x of 3 is going to equal 0 plus 1. And that's what we have right here. X of 4 is going to be 1 plus 1. So, x of 4 equals 1 plus 1, which equals 2. Hopefully that made sense. If it didn't, then I'm going to be leaving a link to a website down in the description bar down below. So if you want to understand the Fibonacci sequence more in depth, then go ahead and check out that link. As well as I got a competition going on where whoever can go down in the comment section down below and leave the syntax for what they believe would be the correct code for the Fibonacci sequence recursive function, whoever can actually get the closest or spot on to what the Fibonacci sequence is, I will be doing a shout out to all of you in my next video. As well as at the end of my next video, I'll be showing all of you the code for this function. But I'm going to be continuing on to the next section of today's video. Don't forget to go down in the description bar down below and leave your best guess. Alright? Honestly, just leave your best guess on what you think the code could be and should be. And if you're correct or really close to the correct answer, I'll be giving all of you a shout out in my next video. Because I'm going to be going on to the next section of today's video where we're going to be making art out of code. Alright, so time to go into time lapse, and all of you enjoy this wonderful music I found out on the web. I'll see y'all in a few seconds. Bye. Alright everyone, so I'm back, and why don't, instead of me running the code first, why don't I explain the code to all of you. So we're actually going to use the turtle library, and we're just going to say from turtle import star. Star really allows us to call, instead of saying turtle dot whatever we want, we're just going to call it straight up, because the star allows us to do that without actually having to do that turtle dot method. Alright, so we're going to say triangle size order. This is going to be our recursive call. And then our base case is if order equals 0, we're going to say stamp. This is our base case. Even though it's not saying return, stamp is going to essentially be doing the same thing. Alright? It's a function built into Turtle that because of how it's oriented and how it works, we can use this as a return statement. Alright? And we can't do that all the time, but because of how stamp operates, it is allowing us to get away with that today. So keep that in mind. And that is, I'm talking about on line 40. Else, on line 41, we're going to go into this for loop, where this for loop is going to go from 0 to 3. Yes, there's a for loop within our recursive statement. Alright? But it's there for a reason. And the reason being is because we are working with a Sierpinski triangle, where triangle always has 3 corners, and because of that, that's why we're saying for I in range from 0 to 3. Alright, remember that range is not actually going all the way up to 3, it's going from 0 to 2, which is essentially 1 to 3. And we're just going to say forward size, so forward whatever this value is, and we're also going to then recursively call triangle, and we're going to take the size and divide it by 2, alright? So it's going to get smaller and smaller throughout this code. And we're just going to say the order of this is going to be order minus 1. That's that's their base call right here. Alright? So, and then after that, we're going to use a turtle method called backwards. So backwards and forward, as well as left, are all built-in functions within Turtle that allow us to do different things. Now, this is just going to be just like forward. So it's going to go up, forward, triangle, backwards, and then it's also going to go left 120 degrees. Alright, this left 120 degrees is hard-coded just because of, again, we're working with a triangle. Now, bear with me. All of you are going to be able to see this triangle in a couple of seconds once I'm done explaining this code. Because once you understand the code, really, you can really recreate this on your own. Alright, and that's what I want, is I want all of you to be able to recreate this function on your own. Alright, and then we're just calling a driver function for the Sierpinski triangle. And the reason being is because I want to be able to call the PU method within the Turtle library, as well as I want my shape to be a triangle. And this triangle and stamp are going to work in correlation, because stamp is going to stamp out a triangle each time. Alright, and then underneath we're going to hide the cursor, and that's what HT stands for. Right 30, this is another hard code one, and speed's gonna be 100 just because I want this code to finish before I hit 30, and I am 23, and then we're calling this function right underneath that. So again, PU on line 49, that is a built-in function within the Turtle library. Shape is going to be the shape that gets stamped in whenever this thing gets called, and that is another function built into Turtle. Hide the cursor, built-in function of Turtle, and we want it to be right 30. Again, all these things are really built-in functions of Turtle except for a triangle. And then screen.exit.lock is just so when I hit run, it's going to be whatchamacallit. I don't want it to close as soon as the code's done. I want it to stay up. So let's hit run. And this is the Sierpinski triangle. We are creating it in real time, alright? Alright, so that is the Sierpinski triangle. Yes, you are creating art. And now you can really understand what I was talking about in today's code. As well as, this is not the only thing that you can do. This is not the only type of art you can do within Python. This is called a fractal, and there are many different types of fractals. And if I hit X right now and then make this full screen, this is another type of fractal called a fractal tree. It is honestly, there's a whole boatload of stuff you can do with recursion within Python. From being able to solve your math homework to being able to create some very sophisticated pieces of art. If you want to learn more about this and this article seems pretty interesting, I will go ahead and leave it down in the comment section, down in the description bar down below. Alright, that is all I got for today's video. If you made it this far, you are truly awesome, and thank you for watching my video to this point. Please don't forget to hit that subscription button on your way out so you can get notified when I post my next video, so you can find out the answer to the Fibonacci effect. Alright? As well as, you're all awesome, and if you enjoyed this video, please consider hitting that like button and leaving a comment down in the comment section down below. Just let me know how your day is, and I'll see you all in my next video. Bye.